All right. Well, I see that it is 1 o'clock, so we will get started here for everybody that's joined us. Thanks for taking some time out of your day today. To join us on this webinar. It's our first one in our second annual Steam Timber. So we're trying to and get our focus all on steam as we enter the colder months. Though it's going to be like 100 degrees here where I live, so I'm not sure where that cooling period's going to come, but hopefully here soon. So that said, we're happy to have Kelly Paffel with us today. He's going to be talking about detecting internal leakage on steam valves. Kelly's a great friend of UE Systems and always has great information to share. So we're thankful to him for taking some time out today to share some information with us. Just looking ahead real quick to what we've got for the rest of our Steam Timber. Next week, we're going to do a webinar where we'll kind of walk you through generating a steam report in our DMS software. So that's going to be a pretty, kind of software tutorial webinar, but I know that's of interest to some folks and should help you, figure out how you need to be doing that, ask any questions you've got. We're usually able to make those a little more interactive because we don't necessarily get a huge crowd, so we might even be able to open up and let people ask questions themselves and things like that. So look for an invite coming out for that later today. And then the following week, we've got Nick Westerberg. He's going to be doing kind of a just almost Steam 101, talking about steam trap selection, installation, and testing. So we'll kind of round out the month with that. And of course, in the meantime, we'll be sending out more newsletters with different articles and videos and tools that you might find useful as we kind of start to get into the steam season. So hopefully you all find that to be useful. Before I let Kelly take over here, I'm just going to go just a couple housekeeping things. First off, we are recording this, so we will add the recording of this webinar to our very large library of webinars like this. So that'll be online if you have to hop off early or you've got some colleagues that couldn't make it. And we also, welcome you to ask questions, so feel free to type those in. There's a little box where you can type them in. I'll be kind of keeping an eye on those as Kelly's going through his presentation, and if it makes sense, I'll, hop in and ask him a question throughout the presentation, or of course, we'll save some time at the end for Q&A. So that said, let's turn things over to Kelly, and we'll let you take it away, okay?
All right. Thank you. Can you see my screen?
I do see your screen, yep.
Okay. But do you just see the PowerPoints, or are you seeing
Nope, seeing
everything?
it, I think, as you would see it, so we're not seeing the presenter or the presentation.
You're not seeing the presenter screen?
Yeah. So we see your slides on the side.
All right. You see it now?
Still seeing the stuff on the sides.
How about now? Good?
Same thing. Sorry. And I'm not sure how to tell you how to fix that. Oh, you need to be in presentation mode, which I suppose is an option.
Show my screen.
Sorry, bear with us, folks. This is one of the hiccups with doing these live, but we do think it's better to be able to host these on the fly here. If you go to slideshow, what is your option when you click on slideshow at the top? And then from the beginning, oh, it's still
Okay.
display settings, because we're still seeing your next slide that's coming. If you click on display settings at the top, there should be
Yeah.
a swap presenter view maybe. There you go. All right, now we're
How
rolling.
about that?
Now we're rocking.
All right.
Great.
All right. All right. Again, I'm here in front of a class also presenting this. So welcome this afternoon. I'm going to be talking about steam valve internal leakage testing or leak testing. And just to go through the and so on, steam valves installed in the plants create a perplexing problem because we don't want valves to be leaking through. Valves leaking through create issues with pressure reduction stations, overpressurization, safety valve relieving, steam valves leaking through on process applications. Then we get heating going down into the coil systems, heat transfer where we don't want that to occur. So it comes up to is how do we test valves for internal leakage? You know, by going up and saying, geez, you know, the valve is hot on one side, hot on the other side, doesn't really work. Temperature, you know, because we talk about energy and everything else today, the thing is 100 psi coming into the inlet of the valve, it's going to be 338 degrees Fahrenheit. Well, energy is going to be transferred from the valve body to downstream, and the valve body downstream is going to be hot. It's just through conduction. So by coming up there and saying, test the valve by temperature is quite difficult to do. It's very difficult. We have to come up with another way of testing. So the thing is that coming up with high frequency has been around for a while and proved extremely successful. High frequency is anything looking above 20 kilohertz in frequency, above the human ear. Anything that's passing through a restriction will cause turbulent flow, which generates a high frequency ultrasonic sound. The ultrasound units will pick up this high frequency. Now, typically, setting up the high frequency units, we want to look at frequencies of 25 kilohertz to roughly around 40 kilohertz, which really gives us the best signature with steam passing through a steam valve. The thing about it is every test method has advantages and disadvantages. So I'll be talking about advantages, but I'll also be talking about some of the disadvantages with it. High frequency ultrasound has been proved to be an easy and accurate test method, 98%. The thing with high frequency ultrasound, I've been on valves as large as 12 inches in diameter, been able to tell if it's leaking in the exact point of leakage on the valve. It's a very easy, but there are a few things I want to go through when you're conducting the test. The next thing is that setting up the ultrasonic units is very versatile, highly accurate, fast, and easy. But the thing about the high frequency ultrasound units, it gives me a display of the ultrasound that I'm picking up, which is a visual, and it also gives me the ability for the user, the operator of the unit, to hear that sound, if they could hear the sound. So the high frequency ultrasound is heterodyne into an audible sound, so you can listen through a headset. So you get two, you get a visual, and you also get a hearing of the valve if it's leaking through. The proper test methods, you know, goes for eliminating outside influences. So unfortunately, there's some in the steam system, there's outside influences, could be generate high frequency ultrasound, and we have to be able to detect it if we're picking it, you know, we have some other outside influences influencing our reading. So I'll kind of go through that a little bit. The other thing is accurate ultrasound testing and accuracy of test results. The thing is that I want to be able to go up to the valve and be able to tell, yes, it is leaking, or no, it's not leaking. So we want a very accurate test. Positive. The positive with using ultrasound, like I said, fast and easy, highly accurate, can detect other defects in the system. It's used for other purposes in the steam system, testing steam traps, things like that. The negatives, you know, training is required. But again, any tool that you use in the steam system requires training. To get a tool and not to have training, you know, you're set up for, you know, failure. So you have to provide training to the people that are going to be using this unit. The thing about it is high-frequency ultrasound is like riding a bicycle. It really is. The more you ride the bicycle, the more proficient you get. So the thing is the more experience you get on with high frequency, the more ability you'll have, the more accuracy of your readings, like riding a bicycle. What generates ultrasound? Steam passing through a valve that's supposed to be closed. The leak path will generate a turbulent flow. The leakage between the valve and the seating surface will generate a turbulent flow, which will generate a high-frequency ultrasound, which this unit will pick up, such as caged valve, globe, gate, butterfly, any type of a valve. The instrument that senses the ultrasound can detect very low ultrasonic levels to very high ultrasonic levels. You have a sensitivity adjustment. Make the unit very sensitive, be able to pick a leak level of 1 × 10⁻², or a very large leak. So the thing about it is understanding what leak level you're picking up. The sensitivity values can be 0 to 10. The sensitivity values can be 0 to 70, depending on the instrument that you're using. The other thing is that on these units you can have real-time, snapshot, and peak hold, which are ability to look at the peaks or just a snapshot or real-time. For testing valves, we always want to be in real-time mode. How to get started? So I got a valve out there I want to test and see if it's seated or if it's leaking through. How to get started? The thing is before you get started, who's going to be doing the testing? You know, how do I select the team? You know, does the person have experience or doesn't have experience? Select the correct equipment. Okay. Years ago, we used to use screwdrivers a lot. It wasn't too safe of a thing because you got too close to the valve. It could be extremely hot, burn your ear. Safety. So today we don't have to do that, but we want to use ultrasonic equipment. Training, you know, what training is required to do the test. Determine the data collection process, which I'll be talking about. Where do I collect the data? How do I collect the data? The thing is that priorities for testing the valves. So if I have to go out and test 20 bypass valves, and I come back and 10 of them are leaking, what degree of leakage? So I set priorities. The ones with the highest ultrasonic level or flow is the ones I'm going to do first. The ones with very low ultrasonic levels, then they're a lower priority. So I set priorities depending on my test results. And set a correction roadmap. You know, we talked about selection standards, installation standards. And then once I have made the correction, you go back and validate it with another testing procedure to make sure the valve is actually in a shut-off position and not leaking. A lot of times we buy valves that leak brand new. So we use a testing procedure to make sure that we're getting valves that do not leak through. 3 major areas of valve. The big one is steam isolation valves. When I go up and shut an isolation valve off, I want the valve to shut off. I do not want the valve to be leaking through. In steam systems, we have to have 2 valve protection. We want to make sure both valves are not leaking through. Then if they are, then we have to shut 4 valves off. Sometimes we have to shut 6 valves off because of internal leakage. So we want to make sure the valves are seating. Another one that's big in the steam system is steam warm-up valves. So any valve that's 3 inch or larger, we have to have a steam warm-up valve. to warm up the system slowly. So we want to make sure that when we shut the main isolation valve, that the warm-up valve is also in the off position and not leaking through. So we want to test the warm-up valve. The next one is the steam control valve application, supplying steam to the plate and frame heat exchanger, the shell and tube, the steam coil. We want to make sure that it's not leaking through. And the other thing is when we set up the control loop, we want to make sure, and I'll be talking about this, where's the breakaway point of the valve. The breakaway point is when the valve will start to pass steam through it. So the thing about it is that the testing points on the piping, upstream, downstream of the valve, we have to take several testing points. As shown on this print, we have test points upstream, 1 and 2, at the valve, at the discharge side of the valve, which is the discharge passage of the valve, is test point 3, and test point 4 and 5. Why are we taking the test points? We're looking to see if we have competitive ultrasound that could be throwing our reading off coming from upstream or downstream, and knock out that competing ultrasound. Now, can you take more than 5 test points? Sure. You can take 10 if you want, but I request that you take at least 5 test points on every test. So the thing is the distance between the test points upstream and downstream. So how far away should I be from the valve? Well, depends on the valve size. A general guideline is I want to be on test point 2 at least 10 inches from the valve, which is 10 inches from the valve to test point 2, and then 24 inches from the valve to test point 1. Now, that will depend on the size of the valve. If I go up to a 36-inch valve, of course, I want to be a little bit further away than that. But it's a beginning. It's a general guideline. And the same thing for the dimensions downstream is to test point 4 to be 10 inches and test point 5 to be 24 inches. Again, I'm looking for the competing ultrasound. Now, reference number is usually on a scale to 100. And for this, this paper, this presentation, I use a number of 0 to 100. 100 means severely leaking or great leakage, and 0, no. So I go to test point 1, and I get a reading of 27. At test point 2, I get a reading of 26. And test point 3, I get a reading of 25, and 3, and then 4, I get a reading of 24 and 25. If all these numbers are close in ultrasonic levels, the valve is not leaking. The valve is not leaking. A leak will generate more ultrasonic sound, then you'll know the leakage is occurring. So on this here, this isolation valve, with all the points pretty well close in ultrasonic level, gives me an indication the valve is seated and it's not leaking through. Now, if I go to the next measurement, which is here, now at test point 1 is 27, test point 2 is 26, but test point 3 is 45. So you see the increase in ultrasonic level, and then it dies down 34 and 25. With this increase in ultrasonic level tells me that the valve is leaking because there is ultrasound being generated. So we determine that this valve is leaking at the discharge side of the valve because of higher ultrasonic level. So then I go to the next reading, and test point 1 is 25, 21, test point 3 is 38, test point 4 is 40, and you see the increase of 57 at test point 5. What that's saying is there's ultrasonic sound being generated downstream, or competing ultrasonic sound. So as I go downstream, the level starts to increase. The sound is coming back from downstream. That is not a valve that's leaking. That's something competing ultrasound downstream. I want to go downstream of the valve, find out what's competing or producing a competing ultrasonic sound, and make corrections to that. The same thing with the bypass. This is the warm-up valve. Sometimes called bypass, so this is really the warm-up valve. Test point 1, 2. At the discharge of the valve 3, downstream 4, and 5. By doing the test method with this is the same test method we would use for the isolation valve. We would take our measurements. If 1, 2, 3, 4, and 5 are equal in ultrasonic levels, the valve is seated. If 1 and 2 are equal to 3 is increased in ultrasonic level and 4 is decreased, then the bypass valve is leaking, the warm-up valve is leaking. So ultrasonic sound is very directional. So by taking these points and see the increase at the discharge side of the valve tells us it's leaking. All ultrasonic levels should be pretty close. Nothing's going to be perfect. They're not going to be 25, 25, 25. Life's not perfect, okay? So as you see, the increase is there's ultrasonic sound being generated. And that's a quite common process that we use on warm-up valves all the time because we want to make sure that they are in the seated position. Specifically, if we go for a shutdown at the end of the year, we want to make sure we know all the valves that are leaking and get them corrected. The next thing is 2 ways to test a control valve for checking steam control valve for leakage and then determine the breakaway point. The same as the isolation valve. I'm going to be doing test points 1, 2, 5 at the discharge point, 3 and 4. So on here they labeled 1 and 2 upstream, 3 and 4 downstream, and then went to 5 to the discharge side of the valve. If I did the test 1 and 2, 5, 3, and 4 were equal, the steam control valve is seated and it's not leaking. If I do 1, 2, and there's an increase at 5, and then decreases at 3 and 4, then the control valve is leaking. If I do a test 1, 2, 5, 3 starts to increase, 4 is higher yet, then the competing ultrasound's downstream. I need to find out what's competing. But not so much as leaking. We do tests for leaking. The other method is, well, this is for the valve. I just went through this for the valve off position. But this here is more what we use ultrasound. When we go to set up a control valve, and it's very important to understand the breakaway point. And people say, what's the breakaway point? The breakaway point is the point where the steam control valve starts to pass steam through it. So this control valve can accept a 4 to 20 milliamp signal into the positioner, or 3 to 15 psi in the positioner, or if it doesn't have a positioner from an I to P, 3 to 15 psi. As I start to apply the control signal into this valve, at what point does the valve start to pass steam? So if it's 4.0 milliamps, I go 4.4 milliamps, is it passing steam yet? Or does it start to pass steam at 5 and 5.5? It's very interesting when setting up a control valve, sitting there and with a 4 to 20 milliamp generator and seeing exactly what point does steam start to pass through the valve. Because I'm starting to set up a P&ID loop. And the P&ID loop assumes 4.0 milliamp is 0, no flow, and 4.4 milliamp, there is flow. If I have a dead band down here on the P&ID loop, the valve doesn't start to pass steam until 4.8 milliamps. It does start to cause some issues with the P&ID loop setting it up and tuning it. Now, if you're just heating water, to 80 degrees C, and you can take 5 plus or minus 5 degrees C fluctuation, it's not a problem. But we get in processes where you have to have plus or minus 0.5 degrees C. So this breakaway point inside this control valve becomes very, very important. Okay. So there's a couple things that we do on the control valves is setting up this control valve for the breakaway point and understanding the breakaway point in the valve, and that's setting up the control valve. Now, the same thing with this technology applied to steam control valves can be applied to utilizing a hydraulic, internal hydraulic leakage, and other valve applications outside steam. I'm just talking about steam today, okay? So those are some of the applications that you have using it. The thing is no internal steam valve leakage. Then we don't have to worry about premature valve failure, because steam leaking through a valve, steam will wire draw the seat area and the valve mechanism, the plug or whatever. The other thing is that we are looking at no component failures within 6 years of installation, period. The steam system, we cannot accept today component failures within 6 years. And internal leakage can cause issues in operation. So by doing this test, then we can determine what's causing it. And then the other thing about finding the leakage and everything else, root cause analysis, determine what caused the leakage to begin with, has to be part of the program. So anyway. And the last is my contact information, and if you have any questions, just let me know. Thank you.
All right, great. So we did have a couple questions come through. So the first one is, so they said, I'm testing at a new facility and our steam lines are all insulated. What testing is possible to do to find leaks in my situation where I cannot test several places upstream and downstream?
Well, the thing about it is that that's a common problem, but what we do is penetrate the insulation with a small hole we call test plug. So you make an opening in the insulation so the probe can go in and make contact with the line. Once the test is done, then we plug that hole with a plug we call test port plug.
Okay. And then let's see, how do you recommend testing or inspecting fixed orifice steam traps? Oh, I think
I recommend not using orifice steam traps. Then you don't have to worry about testing them.
Okay.
You can't test an orifice steam trap. They're always blowing through. So.
Okay. So note to that person. Okay. And then this other person, if valves and steam traps are surrounded by insulation, how do you test them with ultrasound?
Again, if insulation is a factor. So if it's permanent insulation is making a test port where the stethoscope module will go through and make contact with the pipe, and then once the test is done, plugging that port, which gives you access from that day forward, is going up, looking for the plug in the insulation, removing it, and then the probe can go in, which is done all the time.
All right, and last one, at least for now, unless something comes in while you're answering this, can check valves be tested?
Well, that's easy. Yes, check valves can be tested for sure. And in steam systems, a high failure rate in the steam system is people that use swing check valves, which should not be used in the steam system. Any check valve used should be a disc type check valve.
All right, well, those were the questions that came in. So if people have additional questions or want any more information, we can get you Kelly's contact information. Just shoot me an email, and we can get you guys in touch. So as you're kind of digesting this throughout the day, if there's something that pops up, just toss us a note and we'll get that over to them. But Kelly, thank you so much. I just have a couple closing slides here before we let you all go. Of course, you can go if you want, but I just wanted to mention a couple things that aren't necessarily related to steam, but we do have our newest publication, our lubrication ebook. So if steam isn't the only thing you're interested in, we do have that we just posted about a month ago on our website. So take a look at that. And our other kind of new product is our compressed air survey online course, which we've had quite a few folks go through it, and I think people are finding it to be pretty valuable. So if compressed air is something you're also looking at, take a look at that as something that you can kind of take at your desk when it's convenient, and where it's convenient. Then just wanted to show you our leak survey app that we have. It's available now both in, and I need to update this, both in the App Store for iOS and also now for Android. So it's available in the Google Play Store as well. But this is a really great tool where you can actually do a leak survey right from your phone or your tablet. We've had several customers using it, and they've been just raving about it as just a quick and easy tool to get the survey done, and they generate the report, email it to themselves right there from their device. So pretty cool. Definitely check that out if you're doing compressed air leak surveys. And then again, our website, lots of information on there. Not just on Steam, but all the other applications as well. But you certainly, if Steam is something that you're still trying to learn some more about, we've got lots and lots of information up there for you to check out. And our LinkedIn groups, great place to ask some questions there, get some feedback from your peers that are experiencing similar things. So check out our UltraProbe users group and our Reliable Asset World group on LinkedIn, and kind of get connected with those that are doing the same thing as you all around the globe. And then finally, save the dates. We've got our Ultrasound World and Reliable Asset World conferences coming up next May 9th through the 12th in beautiful Clearwater Beach, Florida. So it's never too early to get those dates on your calendar, and we hope to see you down there. With that, I'll leave our contact info up. Another thank you to Kelly for the great information. I'll have the recording of this up on our website in the on-demand education portion of the site later today, so you can check that out. And we hope you'll join us for the webinars we've got coming up the next 2 weeks. With that, we'll let you guys have a great rest of the day, and we'll hopefully see you